Okay, this is the AP Physics problem, practice test 2, question 2. In the laboratory, you connect a resistor and a capacitor with unknown values in series with a battery of EMF equals 12 volts. You include a switch in the circuit. When the switch is closed at time t equals 0, the circuit is completed, and you measure the current through the resistor as a function of time as plotted below. A data fitting program finds that the current decays according to the equation I of t equals epsilon over r times e to the negative t over 4. Using common symbols for the battery, the resistor, and the capacitor, and the switch. Draw the circuit you have constructed. Show the circuit before the switch is closed, and include whatever other devices you need to measure the current through the resistor to obtain the above plot. Label each component in your diagram. So, capacitor must be placed here with the battery in order to create a current as the capacitor charges. The resistor must be placed someplace in the loop in order for the graph to be shown otherwise it would simply dip quickly. The ammeter must be placed in series to the capacitor in order to be measured. Having obtained the curve shown above, determine the value of the resistor you have placed in the circuit. Because it's a circuit, we can use the equation R equals V over I, which is just an adaptation to V equals IR. We use V is given to us, and I can be determined by finding I naught from the graph, as shown here. Here we use 0.01, and then we substitute it, and then solve. So we get R equals 12 over 0.01. We get 1200 ohms. What capacitance do you enter into the circuit to give the result above? Because the time constant T is equal to IR, time constant here, where 4. We take the equation T equals RC. T equals RC. Because we plug in 4 we divide R by both sides in order to isolate the C, and we get C equals T over R. We plug in 4 that we have right here, time constant, and we plug in 1200 from the answer that we got here. So the capacitance turns out to be 3.3 times 10 to the negative 3, or 3.3 times 10 to the negative 3. We are now asked to reconnect the circuit with a new switch in such a way as to charge and discharge the capacitor. When the switch in the circuit is in position A, the capacitor is charging, and when the switch is in position B, the capacitor is discharging, as represented by the graph of voltage V across the capacitor as a function of time. Here's the graph. Draw a schematic diagram of the RC circuit that you have constructed that will produce the graph above. Clearly indicate switch positions A and B on your circuit diagram, and include whatever devices you need to measure the voltage across capacitor to obtain the above plot. Label each component in your diagram. While the capacitor is charging, the voltage slowly increases. Therefore, the capacitor must be placed right here where it can charge when the switch is at A. But as the capacitor discharges, the voltage rapidly decreases. Therefore, the resistor must be placed on top. Furthermore, the resistor allows this graph to be shown without a sharp increase or a sharp decrease. Furthermore, the voltmeter must be placed parallel to the capacitor in order to avoid short circuits. And that is practice test 2, question 2.